guys, Jerry Blum here with another Arduino tutorial series. This is episode 12, focusing on radio frequency identification. As always, it's sponsored by Element 14, and some parts for this week's episode have been supplied by cooking-hacks.com. And those guys are great, so you should check them out. Sorry, it's been a little while since the last video. For those of you who follow my blog or on Twitter, you know that I'm working at MakerBot Industries this summer, so that's been keeping me very busy. It's a lot of fun. You should definitely check it out if you're not familiar with the company. They make personal 3D printers. But it's been a great time, and I'm busy, but I'm going to try to get as many Arduino tutorials out this summer as I can. I have a few suggestions from you guys that I'm going to try to make happen. Alright, so let's talk a little bit now about what radio frequency identification is, how it works, the physics behind it, and then we'll learn how to read RFID cards and tags, and then we'll use that to make a simple security system that you can use to bolt or unbolt a door when someone with an authenticated tag swipes in. Alright, now before we actually make an RFID system using the Arduino, let's talk a little bit about how RFID works. All RFID systems have two components, a master computer of some kind with database information relating to the IDs on the cards. All cards have a unique global identification number, so you can say with confidence by looking it up in a database, if you find this ID, then it corresponds to this information. So it'll be stored in a computer of some kind. We'll be using the Arduino for this purpose. And then there's generally an integrated circuit that works with the coil that reads the RFID information. So hooked up to that, there's a big coil of copper wire, and we'll be playing with one of these in a minute. And that's what we're using to transmit the RFID information, or to get it from the card rather. So on the other end, we're going to have a card of some kind. Could be a passport, an ID card, just about anything that has an RFID tag in it. And over here, you'll see that you've probably seen these before in stores, and they come in DVD boxes and stuff now. And there's going to be another coil that lays flat like this inside the card, and it mimics the copper coil that we have on the other end. And then in the middle of the coil, or somewhere else in the card, there is another integrated circuit that stores information about the identity of that card. So we have the information over here, but keep in mind there's no power supply on this card. It's entirely passive. So how do we read the information off of there if we can't power up the IC? And that's what's great about RFID. So what happens here is we send through electromagnetic induction, we're able to power this and communicate with it. We send a current through this loop over here in a direction that looks something like that, and it goes around the loop, and this creates a magnetic field. And when you get close enough with these two things, you create something called electromagnetic induction that powers this coil and therefore the IC. So what will happen here is this makes a magnetic field that looks something like that, created by the current in this loop here. And then over on the other end, that will induce a current in these coils that is sufficient to power the integrated circuit, get the identity information off of it, and transmit it wirelessly back to the main computer, which has a database that can then look up all the information on it. And that's it. That's how it works. Electromagnetic induction. It's awesome. It's the same way that transformers work. So that's RFID in a nutshell. Now let's go play with it. Okay, here's everything we need for our initial setup. I have an Arduino Mega. I'm using a Mega today just because it's what I happen to have around. You can use an Uno as well. I'm going to only use pins that are available on the Uno also. An XP Shield. We've used this in the past to talk with our XP radios. Today, instead of plugging in a radio, I plugged in our RFID tag reading chip from Cooking Hacks. Don't forget that you have to change the jumpers here when you're programming or using this as a serial interface, because if you're using the Uno, you only have one serial interface, and even on the Mega, we're plugged into the same serial interface that we use to program the board via USB. And then I have a few different cards with different serial numbers on them that the RFID tag reader can read, as well as some keychain fobs as well that also have unique serial numbers on them that we can read and do some simple security with. So let's get our first program written. Okay, next up we're going to get our simple program written that can show us over serial the ID of the card that we're putting up to the RFID reader. Now this gets a little complicated, so I've already written a bunch of it down, so let's go through it. The first thing is up here I just have some variables set that we're going to use to hold the ID of the card as it comes in from the reader. The important stuff starts in the setup. Serial begin we've done before, that's just starting our serial connection on our Arduino. Here though I've set the baud rate to 19,200 as opposed to the normal 9,600 because this is the rate that the RFID chip communicates at. That's no big deal. The only thing you have to make sure is when you go to your serial monitor later that you set the baud rate correctly so that you don't get gibberish on the screen. Okay, here's the potentially confusing part. You can see I'm doing a serial.print here. So this will print that information out to the computer, but more importantly, it will print the information to whatever is connected to the serial bus, in which case the XB shield with the RFID tag reader attached. So it's going to be expecting all this data, and what all this data is doing is putting it in the proper mode. You can say I've sent it a header, a reserved byte length, a particular command. This command is what puts it in auto read mode, some data that goes along with it, and some blank password information because we're not going to be using that right now. And then last up is a checksum that ensures it received the data that it actually intended to receive. So let's look at how I actually figured out that command that I'm going to send. It's actually pretty straightforward. If you go to the data sheet, it talks about the serial protocol structure for the RFID reading chip. And if you look at this table here on page 19, it says exactly what we need to send it in order to put it in a particular mode. So there's a header, reserved, length, command, data, and checksum, which are the things that I just showed you. So if we want to put in auto read mode, for example, we can go to the section of the data sheet that talks about auto read mode. In this case, it's page 28. And it tells you all the things you need to fill in to do that. So the command, for example, is 0x87, so it's 87 hex. That will put it into automatic read mode. And automatic read mode basically just waits until a card is detected and then reports the serial number. It's very straightforward. And then there's some data that goes along with it that we will fill in for our particular setup. And conveniently enough, on the next page, there's an example command that does exactly what we want. We're going to be reading decoded cards. We just want to get the serial number straight off, no password, nothing extremely complicated. And it gives us the exact command that we used. And if you recognize this, these are the exact same numbers that I just showed in the Arduino program. So you can see that there's a header, just a fixed digit there. The length of the payload is 9, because that's the amount of data that we're sending. 0x87 I just showed you earlier. That's what tells it to enter auto read mode. And then there's all the settings for auto read mode that are particular to the kinds of cards that we're using. And these are basically the default values. For the password, we're not using a password, so we basically just pass these dummy values. The checksum is the addition of all these values in hex that gives us a value so that we can show that the data got there properly. So that's that. That's all the information that you need to send it to put into auto read mode, and that's just right there, literally copied straight out of the data sheet. I didn't have to come up with any of this on my own. Next, we're going to give it a quick delay to let it enter auto read mode, flush the serial buffer, which we've done before, put a new line and tell us on the serial terminal, okay, we've started it, and we're ready to start reading some values. So how do we now actually read the values? That's important, obviously. So the first thing we're going to do is go back to the data sheet here and see what form we expect the response to be in. And on page 20 of the data sheet, it says exactly that, the response structure for the commands from the chip back to the host, in which case, in our case, is the Arduino. And this is what we're going to get back. So we're going to get back a header, which is OA0xFF. So this is perfect. That means we can look for that value because that'll only come in the header, and it'll say, okay, when we get that value, we're at the beginning of a response from the chip, and we can look however many bytes in and get our response, which will be the serial number of the card we're interested in. Just like before, there was a reserved bit, there's a length, the command for the response being sent back, and most importantly, the response, which is the data that we're interested in. So we can basically just count however long these have to be, ignore them, and then grab the response, which is the serial number, that 5-byte serial number that we actually care about. So if we know that we're looking for 0xFF to come back first, then we can go ahead and look for that. So if you remember before, up top, I had this value called val, and we're just going to set that equal to serial.read. And serial.read is just going to look at the serial bus and read it 1 byte at a time as it comes back from the RFID chip. So while that is not equal to 0xFF, we know that we have to keep looking for a time when it is. So each time around, we're going to read the next bit or the next byte from the bus until we finally get one that's what we want, and then we'll exit this while loop and get ready to look at our data. And I'm just going to put a delay in here so it's not reading constantly. Every second it's going to sample data again. Okay, so that looks good. That should get us through the data. And so once it actually gets past this while loop here, that means we found data. We're ready to start reading some stuff in. So let's get rid of the garbage first. Every time you do read, it reads in 1 byte and removes it from the incoming buffer. So we've already read the header, so that's gone. And if we look at the datasheet again, we know that after the header, there's a reserved byte, a length byte, and a command byte. Those are each 1 byte, so we just have to run the read command once for each of them to get rid of them, because we don't really care about them. So let's do that. Oops. Okay, so that should take care of our reserved length and command bytes. Now here's data that we want. If you remember earlier, I made this data array that's 5 long that will hold each of the bytes of data. So into each of these, we're expecting 5 bytes because we know that the serial number on all RFID cards is 5 bytes long. So we can read this in to our data array by reading in 1 byte from the buffer at a time until we have all the bytes. Okay, so those are all of our bytes. We now have data 1 through 5 into our array that we can now use. And last but not least, we want to read out the checksum. I'm not going to bother actually checking it. I'm going to assume that we got the data we wanted, so we'll just basically throw that out by reading it and not doing anything with it. Just for now, it'll make things easier. Okay, so the next thing that we're going to want to do here is, now that we have this data, we want to identify what the serial number is on these cards that we have, so we can mark it down and use it in our database as a security measure to ensure that they are the cards that we want. So I've already written some of this code here. And so basically what this is going to do is it's going to, once we found a card, because it got past this while loop and it's read the data in, it's going to say, okay, I found a card, and then it's going to print out the serial number for it, which is stored in this data array. So we'll go through a for loop like we've done many times before. It'll start at 0 and go up to 4, and for each one it'll print out the byte that it found. The only important thing to consider here is if you have a byte that's greater than, in decimal terms, 16, or that's less than 16, then it's only going to print out 1 digit, and that's not really what we want. So for example, if the byte happens to be 9, it's not going to print out 09, which is what it should print out. It's just going to print out 9. So it's important that if it's 16, because we're working with hex and hex is base 16, we need to print out a 0 first, so that we know the actual serial number of the device, because the zeros are relevant in that serial number. And go ahead in your code and try commenting this out and see what happens when you don't have the 0, and you'll see that some pieces will be missing, and that's no good. So this is perfect. It'll print out thing one after one, and then put a line break when we're done, and then start reading the next chip, or the next card that we pass in front of it. So this should do what we want pretty simply, just show us the serial number of the cards that are detected. So let's load this onto our Arduino and see how it works. Alright, so the code is loaded onto the Arduino and we're ready to test it out and see how it actually works. So the first thing you have to remember to do is to move our jumpers back over. I put them over on the USB pins so that I could program it. So move those back over to the XB pins, or the serial connector pins on the XB shield. The next thing we'll do is grab one of our cards and pass it over the reader. You'll see that it blinks red, indicating that it's reading. And if we look at the screen, we can see that it found a card. Great, and it lists out the serial number, and it's doing exactly what we want it to. So that's really great. Now let's try another card. We'll grab this one. And we can see that it finds that one, and it has a different serial number, of course, as one would expect it to. And we can look at the tags too, and just see what the serial number is on each of them, and of course they'll all be different. Okay, great. So it works, and we can grab the serial numbers off. So the thing we're going to do now is grab the 2 of the serial numbers that I want to use for people to actually gain access to our room or a vault or whatever and put them into the security system as recognized users. So we'll use the first two that we gathered for those, the ones from the cards, and people with tags won't be allowed access. So let's now program that in so that we can see who's actually entering by associating them with a serial number. All right, so we have some serial numbers that we want to save into the system and allow access later on. So now that we have them, I wrote them down from the screen earlier, which you should have done looking at the serial monitor, or if not, you can go back and read them again. But I'm going to note them down now and make them into byte arrays here. So I'll allow myself and my brother, David, access to the room, and I'll note down the ID numbers for each of our cards. So we can make an array of data pre-populated. So here this is just an array ready to be populated. We can fill it in with data by using these little curly brackets here and filling in the data straight up. So in case you're not familiar with it, the 0x at the beginning indicates that we're using hex data. And hex is just a base 16 number representation. So each of these two digits can be between 0 and F, where A, B, C, D, E, and F are 10, 11, 12, 13, 14, 15, so that you can continue to represent them in one digit, whereas normally you can't do that with numbers above 9. So that's all that means, and that's because we're representing as bytes here. So we can pass that data in that I saved as our ID numbers into this array here. Let's make sure I have that right. Yep, okay, so that's mine. Now let's save David's, and we'll use this to compare to the data that we're taking in. Okay, and those are our two serial numbers that we want to recognize as known addresses that we're going to allow entry to our system. Okay, so now that we have these saved, let's go ahead and look at where we're actually getting the serial numbers back from the cards, and we can handle these so that we can see if they're recognized in the system. So down here where we're identifying the RFID card, we're going to start off by assuming that it's either my card or David's card, and then as we go through each byte, if it doesn't match up, we'll say, sorry, false, you're no longer permitted. And this is just a very simple way to go about doing this. So we'll use a Boolean, which is just true or false, and we'll call it jcard equals true. So we'll assume by default that it is my card and that it is David's card, obviously, though it can't be both. And we'll set David's true by default as well. Okay, so we can go through, look if a card is found. Now what we'll do is each time we get our byte of data that we would normally just print out to the screen, instead of just printing it out, we're going to do a little check here. Check the byte. So if that byte, data I, so the ith position in the data array, if it's not equal to the Jeremy array at that same position, then we know that it can't possibly be my card because the bytes don't match up correctly. So we'll just use a shorthand if statement here, and we'll change this to false. So basically it just has to hit this once, only one byte has to not match up, and this will be changed to false, and then we'll know that it wasn't me. And we can do the same thing with David's card here. So if data I is not equal to David at that same position, then D card will also be false. Okay, so that's pretty straightforward. And then once we get to the end here, in addition to just printing out the serial numbers, we can say, oh, hi Jeremy or hi David, depending on who it was. And then in the next step, we'll use that as part of our security system. So if jcard is still true, then it must have been my card. So we'll serial.println hello, Jeremy. So it'll know that it's me because it has my ID number. And then the same thing goes for David's card. And most importantly, or this actually can be an else if, because it'll never be both of them. Most importantly, you need to have an else statement because most of the time it won't be either of us. It'll be some deviants trying to get into our system. So if it's neither of them, we need to do a print line and say, get out of here. Because they are not supposed to be in the system. They are not a recognized serial number. And then we'll just put another blank line after that to keep the terminal looking clear. Okay, that should do it. Don't forget to move your jumpers back to the USB position and then hit program, and we'll see how that works. Okay, so I've programmed it and I moved my jumpers back to the shield position, and now we can read some cards and see if it actually recognizes them. So let's start off with this one. Put it on the reader, and we can say, okay, card found, so this one must be David's. If I try this guy, it finds that it's Jeremy's. All right. Now, most importantly, though, let's try one of the ones that is not belonging to us. And sure enough, yeah, get out of here. It doesn't recognize this tag as a valid ID number in our system, so it won't let us in. All right, great. So now that we have that simple system down, let's go ahead and expand this and make it a little bit more complex and add a security aspect to it. Here's the schematic that I've put together for our final system, and this will be available for download, of course, on my website. So what I want to do here is a few things. First off, we're going to add a speaker to the Arduino that will play some tones based on what IDs were detected. So if the correct ID is detected, it'll play a certain tone, and if the wrong ID was detected, it'll play a do-do-do-do kind of thing, like you failed. So that's one thing that we're going to add. The next thing I want to add is a servo. So we've played with a servo before in episode 5, I believe it was. So what we'll do here, and what this is perfect, I'm not going to actually hook it up to a door, but a servo is perfect for because it goes from 0 to 180 degrees, is you can start in one position, and if you give it the right ID card, the servo will open in one position for 5 seconds, let's say, and then close again. So this is perfect for like opening a safe or unlocking a door when you swipe an ID card in front of it. So we'll set that up as well. And then the last thing I want to set up as another layer of security here is implementing the sleep functionality in the RFID chip. So if you look at the data sheet for the chip, something you find that's very interesting is that on pin 12 of the chip, there's a sleep functionality. And if you keep pin 12 high at a logic 1 or 5 volts, then that chip will fall asleep. And what that means is that it won't be able to read cards, but as soon as you take it out of that sleep state, it'll be able to read cards again. So by adding a push button here that you have to hold down in order to activate the RFID tag reader, it's just another layer of security, and it means that it can't accidentally pick up someone that's walking by. You have to actively be at the reader and press the button if you want it to read your ID card. So that maps to pin 5 on the actual breakout board that we're using. So what we'll do here is we'll have a pull-up resistor to 5 volts, about 1K, let's say, that goes from pin 5 on our RFID control board up to 5 volts. So by default, we'll have this switch here open, and this pin 5 will basically be connected up to 5 volts, and that'll keep this in sleep mode. And then so to indicate that, what we'll also have here is we'll have an LED connected through a current limiting resistor, although you don't actually need it because you have this resistor up here, but put it in there anyway, it doesn't matter. We'll have a red LED there. So when this switch is unconnected, no one's pushing down or actively trying to use the system, this LED will be connected up to the 5 volts as well. So when there's no one using the system, this red LED will be on, indicating that the system is inactive. When you close the switch, it'll bridge ground first off to the LED, and so no current will flow through the LED, so that LED will turn off, indicating that the system is active, and a green LED will turn on, and that LED is located on the actual RFID board. You'll see it in a second. And the other thing that we'll do is when you bridge that to ground, that'll overcome the 1K pull-up resistor that we have to 5 volts, and so it will essentially connect ground through the switch, and we can follow it around and over to pin 5 on our board, which will bring that into active mode and allow us to read cards. So here's the finalized system. Let me show it to you wired up, and of course you can download this schematic and a breadboard image version of this schematic that's a little simpler to follow with the video. So here's the system actually wired up here, just like I showed in the schematic. The great part about the reset switch that I talked about is it requires absolutely no software to make work. It's ready to go already. You can see I have it hooked up as shown. This is the red LED I was talking about, 2 resistors in the switch. When I hold the switch down, the LED goes off because it gets connected to ground, and the green LED on the RFID board goes on, indicating that it's ready to read cards. So that's already ready to go. That's simple. The only thing that we actually have to program in here is the code for the speaker, which I'll show you how to do in a minute, as well as the servo code that will open and close the servo based on what tags we read. So let's go take a look at the software and get our security system set up. I've gone ahead and finished up the code here. I'll just walk you through it to save time. All the servo stuff we've done before in tutorial 5, I've included servo.h here. Same thing we did as last time. And then down below I added servo code. And then the speaker is new, obviously, but you can learn all about that if you go to File, Examples, Digital, and go look at Tone Melody. I literally just stole it right out of this file, quite shamelessly, I might add. So all that, the tone setup in the Arduino is it's sending different frequencies to the speaker via pulse width modulation, the same thing that we've used to control motors and LED brightness in the past. So this includes a pitches.h file, which I stole, and that just maps frequencies to notes on the scale that we can then use to make music. And if we look at how they set up the speaker here, it's relatively simple. They include that file, which I include in mine as well. I copied it over to the local directory. They make a little melody, so this is just an array that has some notes in it. So you just pick the notes, and these are all different sounding notes, different frequencies. You put them in order. And then for each of those notes, you pick a duration. And if you want a break, you just use a 0 instead of an actual note value from the pitches.h file. And so the way this works here is, 4 is a quarter note, 8 is an eighth note, etc. If you're familiar with music, then you'll understand that. And then all you do is when you actually want to play the music, you put in a little for loop, you have it go through the total number of notes, and for each note, it just figures out the duration and uses tone, which is a standard Arduino function. You can read about it on the arduino.cc website, where it puts it on pin. In this case, it's pin 8, but we'll actually use a variable. It grabs that melody, so that frequency that we're going to use, and then the duration, which is what we set in this array up here. And then it just plays it. It adds a little pause between notes and then plays the next note. And it's as simple as that. So I literally just stole that file and mashed some notes together until it was something that I thought sounded nice. So all I put here is a little melody for me and for David and for failure. So for the Jeremy melody, it plays one group of notes, and you can see that I have the notes and the durations there. For David, I defined some different notes, just different octave. And then for fail, it plays a little failure noise, and I have the note durations for that as well. The other difference in this code is that I've, of course, defined what pin the speaker is hooked up to. It's pin 8 through a resistor. And what pin the servo is hooked up to, I hooked up to pin 9. And since I'm only using one servo, I didn't bother using an external voltage source. The built-in 5 volts should be sufficient. In setup, you have to add the servo pin attach. So I called the servo object door lock. You can see I created up here, servo door lock, and here I attach it. And again, this is all from tutorial 5. This is all repeat information. All this is the same. I still identify the RFID card, check if it's Jeremy or if it's David, and if not, it's false. And we can print out success. The only difference here now is instead of just saying on the command line, hello, Jeremy, we get a little bit more complicated. So if it detects that it's Jeremy's card, I added this for loop here that's that goes through the notes, just like I showed from the melody file that Arduino provides in an example, that just plays my little music. Same thing goes for David. If it gets David's, it plays the David note setup, which I denoted with a D instead of a J. And then last but not least, if it's not recognized, it plays the failure note sound. And then, of course, we have to worry about the locking mechanism. So if it's either David's card or my card, remember the double pipes there mean or. So if this is true or this is true, either of us have access, then we'll say to the servo, go to 180 degrees, wait there for 5 seconds, and then go back to 0 degrees. So that should give you enough time to open the door and then have the lock return to the initial position. And that's it. This is our new code. This is our nice little security system. So let's download it. Make sure you move the jumpers to the USB programming position, and we will see how it works. All right, so we've programmed the system. I've moved the jumpers back. Don't forget to move those back or it won't work. And we're ready to test out our new RFID-based security system. So let's grab one of the tags that we know should work. This is either mine or David's, I'm not sure. And first off, let's just see if our reset functionality works. So if I hold the card there, nothing happens, which is exactly what we would expect because the RFID tag reader is in the disabled or sleep position. However, if I push this button down, the red LED goes off, green LED goes on, this is ready to read. I can pass it in front of it, it reads it. We get nice little music. It turns the servo to the open position, and then it turns it back closed again. And the serial display on our computer also says, "Hello, Jeremy." Okay, great. Now let's try one of the cards that shouldn't work. So once again, won't work unless we hold the button down. It'll read it. We get a failure sound, and of course the servo does not open because they're not permitted entry to the room. And serial says, "Not recognized, get out of here." Now let's try David's card. Hold down the button to activate the system. It plays a different tone than mine, but still a success tone. It opens the servo, waits 3 seconds, closes it again, and it displays on the computer, "Hello, David, we recognize your number, and you're ready to enter." So that's it. That's our security system. You can have a lot of fun with this. All the schematics and code and everything are on my website. If you have any questions, you know where to go. So have fun. I'm sure you can make some really fun security systems with this setup. Thanks for watching this episode of my Arduino tutorial series. I hope you guys enjoyed learning about RFID. And if you come up with any cool projects, be sure to send them my way. I'll either feature them on my blog, or I'd just love to see what you guys are working on with radio frequency identification. If you have any questions or anything about this, feel free to post it on element14.com, on my blog, or on the comments on this YouTube video. And all of the schematics, source code, parts list, everything is available open source on my blog, jeremyblum.com, and on Element 14. And there's links for all of that in the description of this video. So go check that out, have fun, and let me know how it goes. I'll see you guys soon with another tutorial video. Thanks. Thanks to Element 14 for helping me to sponsor this video series. They were kind enough to provide a lot of the materials that I'll be using to create these tutorials. Feel free to go visit their website at element14.com. Check out their community, which is a great place to talk to people about electronics, the Arduino, and basically anything else engineering related. And they also have a store where you can buy a lot of the parts that we'll be using in these videos.